Okay, I have solved this problem before, but I want to redo it to make it more clear. So in this case, so we have two balls. One ball is dropped from, a height of h. So this is our, let's call it B1. And at the same time, another ball, B2, was thrown up, right? So I'm going to put the direction. So I want to resolve this to make it much clearer. And this was, at t equals 0 for both of them, right? And at some instant, the two balls meet with each other, right? So let's say somewhere here, right? So we have the, ball one is still going down and ball two is going upward, right? So since our reference is the ground, really the very key point I want to like bring here is the height, all right? So let's call this y of t. And at the time the two balls pass each other, that means they're gonna be at the same height from the surface of the earth, right? Also, it's gonna take them the same time to pass each other. So y1 of t equals y2 of t. That's the first statement here. And then the other one is time 1 equals time 2, right? So now just leveraging our equation, which is y of t minus y naught equals v naught t plus or minus 1/2 gt squared, right? So ball one, again, let's just write down the expression for ball one. The initial velocity is 0. However, for ball two, we have to throw it upward with initial velocity of v naught, right? So now let's write down the expression for the two. Y1 of t minus, so y naught, so in this case another thing, y naught of 1 is h. So it started with some height above the ground h. And it's a free fall, so velocity is 0, so this part of the equation will be 0, minus 1/2 g's, let's assume 10 t squared. So this gives us y1 of t minus h equals negative 5t squared, right? This is our first equation. And then the next one is for y2 of t minus y naught equals v naught t minus 1/2 gt squared, right? So here it started from the surface, so y naught of 2 is 0, right? So this component is 0. So we have y2 of t equals, and then the initial velocity is v naught t itself minus 1/2 10 t squared. So this gives us v naught t minus 5t squared, right? So we have two equations now. However, we also know that y1 of t equals y2 of t. So this one, I'm just going to rearrange y1 of t. So this is h minus 5t squared. And then in this case, y2 of t is v naught t minus 5t squared, right? So now we just need to equate the two. So this is h minus 5t squared equals v naught t minus 5t squared. So here, these two will cancel out. So that leaves us with h equals v naught t. And the time is h over v naught. That's when the two balls pass each other. So this time t1, t2 equals is h over v naught. And if you're asked to find the height where they meet, you just really substitute for time. So let's take y1 of t equals h minus 5t squared, and this becomes h minus 5, and you replace h over v squared, and this gives you h minus 5h squared over v naught squared. So this is when they pass each other, the height they pass each other. Thank you.